Like the first time I ever recorded my lecture, I put my water bottle down right in front of the camera. And like, it was an MC Escher thing for the rest of the time. Okay, let me ask again. Everybody's got that practice quiz for the probability stuff? Okay. I have the answer key.
Yeah.
It's actually done by computer. I typed it up so you can maybe read it. Did I already put it up on? No, that's your own thing. Okay. I don't think I put it on Canvas, did I? So let's do this. Let's do a few things. Let's talk about the formula sheet. Then I'll see if any of you guys have any specific questions from homework or the practice quiz, and then we'll move into chapter 4. So what you can do if you want to, you should have a formula sheet from test 1, right?
Yeah.
So if you want to, you can keep adding to it, or you can make a separate one for this quiz, and then for the final, you just kind of bring all your formula sheets. Does that make sense? It's up to you, however you want to do it. So this one's going to be short and sweet, right? What formulas do we have? We have one formula for the probability of what? A or B. And OR is basically what operation?
Addition.
Addition. I love it. That's a great thing to remember. OR is basically addition. And the word basically is doing some work. Because you're not just adding, you're subtracting off anything you're counting twice, right? So that's why I say basically addition. So it's the probability of A plus the probability of B, but then you might have double counted. Oh shit. When you subtract anybody, I might have double counted. Obviously, anybody in both groups, I would have double counted. Okay. And then, of course, we got probability of A given B. That's a new marker. Dang. Okay. Anybody remember what that is? It's the ratio of something. Yeah, it's the and divided by the given. So given is and divided by the thing that was given. Which kind of makes sense. If I'm given that B happened, then the bottom is going to become related to B. Because that's what I live in. I can throw everything out. That's not B. Okay. Now comes the suckiest one because there's options. So I don't know if you're doing your homework, you've run into a few places where you had to figure out and there are two options, right? Probability of A and B is either the probability of A times the probability of B given A, or it's the probability of B become a B. There's sort of an A and a B times the probability of A given B. So fundamentally, OR is PA plus PB with an adjustment. And is PA times PB with an adjustment, right? And do you always have to do the adjustment? No. If it's independent, I really want this to make sense. When we were doing the haunted house problem, right, with the Democrats and the Republicans, when I did it with replacement, I just directly multiplied probability of Democrat times probability of independent, whatever shit, right? It was when it was without replacement that I had to stop and think, oh shit, what's it become now? Given that I picked this kind of person, what's the probability I then pick this kind of person? That's why we had to stop and think, what changes, right? That's exactly what the formula is telling me. The successive things I might have to be careful. Really want that to make sense. Okay. And that's it. That's chapter 3's formulas, right? Then you have two ideas, which ideas don't go on formula sheets. Too bad. So you got the idea of independence, right? And you got the idea of mutually exclusive. So let me let you guys finish copying this down. surprised nobody's asked a few certain questions out of the homework. Let me put it up here, I think. So I'm gonna become a student for a second. I'm gonna ask a question before you. I was like, something's gonna get in my eye. Just get my bad eye. That'll be fine. Did you see that?
Yeah.
It had a little diagram with an eyeball saying, "Don't look directly at the light." Is there like somebody staring at an eclipse? I don't know, some kind of state. Okay. Well, that's my email. Let's not look at my emails.
Let's take a look at it.
Oh yeah, this is one of my classes had a positive case, and I was waiting. It was just a matter of time. That's exciting. Okay. So this let's see if I can find it. All right. There is this problem. Where are you, problem? Where the hell? Oh yeah. All right. So they're kind of like right next to each other. How am I gonna do this? This is gonna work. It just is. Oh yeah. I could try to become smart. There we go. Jeff is sort of smart. Yay. All right. So there's two kind of problems in a row. Can you guys see that all right? The sun is turned on a little bit. All right, there's this one. The Latino Californians wanting parole, life in prison, whatever. Right, you with me? So you guys, if you haven't done the homework yet. All right. And notice that they tell me several probabilities in the write-up. So let me see if I can zoom in. 48% of all California registered voters prefer life in prison without parole over the death penalty, blah, 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 right? Event C is preferring life in prison without parole. So 48% is the probability of C. Does that make sense? The first, and look at the first question. What is the probability of C? Easy as shit, because the problem just told me. Same thing for number 45, same thing for number 46. There are 3 percentages that directly relate to probabilities in the write-up. Are you guys with me? So the first 3 problems, there is no work to do. You just identify which probability relates to these situations. What does this one mean here? C is prefer life in prison, what is it? Or the death penalty, yeah. Prefer to live over die, that's amazing. Prefer the life penalty, given that they're Latino California, right? So out of Latino Californians, this is the percentage that prefer life in prison over the death penalty. Right, guys? And if you read through the paragraph, they say almost exactly that. So that would be the number you would put for number 46. Are you guys really actually with me? Okay, some of you guys gave me no answer, so I'm just going to pretend like your answer is yes. Then there's a problem number 80, which is essentially the same thing, just with more parts, right? Okay. So it's got, where are we at? Supporting same-sex marriage. They said that it was important to them, and 18 to 39 years old. If you read through it, they give you 4 percentages. One of them is hidden. See the 6 and 10? That's 60%. So the first 4 questions are no work. You just identify which percentage goes with which, right? Okay, good. And then we got this guy. Jeez. Starting at number 40 there. Okay. Has anyone done this problem yet?
No.
Number 40? All right, let's read through it together. Right. E and F are mutually exclusive. Probability is 0.4. Probability of F is 0.5. Find the probability of E given F. The mistake people make is they go right past that first sentence like it's not even there, when it is the most frickin' important sentence there is in this problem. Okay, so now we gotta remember, and I don't think I've talked much about this, but what does mutually exclusive mean? I think we did talk about it a
They're
little bit.
independent?
No, hell no.
No, okay.
Definitely not. So it's impossible to be independent if they don't include each other.
Okay.
So if I walk into a room, right? If I walk into a room and there are bowls of ice cream and there are bowls of rocks. Okay. There's 5 bowls of ice cream, 5 bowls of rocks. You with me? I'm blindfolded. If I pick up one thing, what's the probability I picked up ice cream?
50%.
50%. Is that cool? That's half of all the stuff is ice cream. You with me? That makes sense. All right, take my blindfold off and I see that it's rocks. What's the probability that it's ice cream now?
0.
So, knowing rocks happened, ice cream can't happen. Its probability changes. Totally dependent, right? But can you be ice cream and rocks at the same time? And don't give me the, well, they make ice cream look like rocks. That's ice cream, right? Can you be ice cream and rocks
No.
at the same time? No. If so, a lot of us would go on a lot more hikes, right? Freaking ice cream everywhere. Holy shit. No? Okay. It's just for me. So my point is this. Mutually exclusive means they can't happen at the same time, which means if A and B are mutually exclusive, let me write this on the board, and then, well, let me write it over there. Why not? Ba-bum. We'll do it live. Let me see. Here we go. Do you have paper, Jeff? You sort of do. You don't really. That sounds about right. Yeah. All right, let's see. Do I have paper over here? Not really. Are you paper? Your paper? I can use you. Here. All right. If, where are you now? Okay. If A and B are mutually exclusive, then the probability of A and B is 0. Holy shit, let me zoom out a little bit. So if a problem says E and F are mutually exclusive, you do not go, you stop and you write down what?
0.
No, be more specific. If it says E and F are 2 mutually exclusive events, what can you write down?
It is impossible for them.
No, don't tell me
Okay.
words. I want probability symbols equals a number. Look, if A and B are mutually exclusive, probably A and B is 0. If E and F are mutually exclusive, then, of course it is. Probability of E and F equals 0. Yeah, I love it. Right. A and B are nothing special. Let me call them E and F instead. The idea behind the words is what's important. If 2 things are mutually exclusive, the and of them is 0. They cannot happen at the same time. Okay. So looking back at this problem. Oh my goodness. Several puberties. Number 40 says E and F are mutually exclusive. What do you immediately write down?
E and F, or probability of E and F equals 0.
Now somebody else help me out. They asked me for this. They asked me for the probability E given F. Can somebody tell me what that formula is? Maybe it's up on the board. I don't know.
Probability of E and F over probability of F.
And what did we just say is true about a part of that formula?
And probability of E and F is 0.
Yeah. So therefore the probability E given F equals 0 divided by who gives a shit? What do you get?
0.
0. You can't do that problem if you just go right past the first sentence. You're screwed. because the first sentence has everything you need. Now, don't get too excited. I'm not going to do all of these for you. So now you know what mutually exclusive means for sure. And we definitely talked about this, but it is freaky as shit. I understand. If A and B are independent, and the probability of something equals the probability of something. I don't know. Can somebody help me out?
Probability of, do you want letters?
Yes.
M equals probability of H.
Oh, neat.
That's Madison Hall.
Oh, okay. So I need something that captures the idea. That doesn't capture the idea.
That's my name.
I love it. I'm with you. If A and B are independent, I really want you to answer it. What is the only probability that we do that looks at how they interact, how two events interact? I don't know.
A given B?
Yes, the given. That's the only probability where I know one of them happened and I'm seeing what happens to the other one. What's up?
I was laughing.
I understand. I saw that.
Okay.
Yes, maybe. I love you guys so much. So if you haven't written this down yet, this is a huge note to take. If I ever ask you, are this and this independent, the only way to answer that question is to look at the given and compare it to the original. So if I know things are independent, the probability of A given B equals the probability of A, or I would have accepted B given A equals the probability of B. This is one of the things, and don't feel bad about this. This is one of the things that frustrates me the most about any class I teach, this idea right here. What does this say? If B happens, does A care? If B happens, does A change? What does it say? The probability of A given B happened equals probability of A. Did A give a shit that B happened? I love you. You guys are, I'm sorry. You guys okay? Everybody's looking at me like, makes sense, dude. All right. This symbol means B has happened. What's the probability that A happens now, right? Like I've taken a Twix out, so probably I get a Snickers on the next go, right? So if this is true, if the probability of A given B is the same as the probability of A was before, then obviously A doesn't care that B happened. B happened, did A change? That says no. Doesn't it make sense that we call them independent then? B did not change A. So what drives me insane is students check everything out except the given. That's the only probability that shows you how they interact. Okay, maybe. I really want that to make sense. And I'm not able to read you at all. All right. You all wear your emotions on your mouth maybe, so I can't see it. Okay. So like on number 41. I know that J and K are independent. What does that mean? What can I write down as true? If J and K are independent.
Probability of J given K is the probability of J?
Yes, for example. Or the probability of K given J is the probability of K. You know those two things are true. If they tell me they're independent, I know they don't affect each other. Which makes the question frickin' easy as shit. But if you just go right past that first sentence, you're dead. There's no way you can get it.
So would that equal
Jimmy,
0.
Jimmy. Okay. I've done enough of these, so don't do that. Everybody can do it themselves. So these should all be very easy if you write down for yourself what the first sentence tells you. That first sentence tells you everything you got to know. Does that make sense? We're so used to skipping the words and then we go to the numbers, right? A lot of students, they have a word problem. The train, who gives a shit about the train? 60 miles an hour, there's a number, let me write that shit down. That sentence is everything, right? And this kind of problem. Okay. Oh, let's see. Anything else? Any questions from homework, from the practice
Can
section.
you please clarify number 36?
36.
Like, how do we do the sample? Like, do you-
Oh yeah. Sample space is just the collection of everything that could happen. So if I said create the sample space for picking one card, you would actually have to write ace of hearts, two of hearts, three of hearts, blah, 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 ace of diamonds, two of diamonds, three diamonds, blah, blah, blah. It's the collection of everything that could happen. This problem is a little weird. 8 fiction books, the rest are nonfiction. They're all numbered 1 to 8, 1 to 4. So if I pick one book, give me one thing that could happen. If I pick one book, what could it be?
Either fiction or nonfiction.
No. Tell me, give me an exact
Fiction.
example.
Fiction.
More than that. I picked one book. You just told me about 8 books. I want
Number
one book.
7.
Good. Fiction number 7, yes? If I pick one book, it's going to have to be that specific. It's got to be fiction or nonfiction, and it's got to have a number on it, right? So I could pick F7. So can you just finish that list out of everything that you could pick?
Yeah.
That's the sample space. Sample space is just a collection of everything that could happen. No?
Yeah.
There's a problem later where you roll a die twice.
Oh my gosh.
You've done it? It's not that, trust me. It could be so much worse. What if it was rolled 3 times? Oh, screw that shit. You get huge sample space. If I roll a die twice, give me one example of what could happen. 1 in 6, right? So you start to get a little crazy, but you have to do it in a methodical way. So 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. 2, 1, 2, 2, 2, 3, 2, 1. So you should end up with, of course, 36. 6 by 6. You should end up with 36 total things, yes.
So we just write them down, we don't write no words with it?
For part A, it's just writing down the sample space. Yeah, you don't need
For
any words.
36, like it's-
Not 36, I'm sorry, this is the later
Yeah, yeah.
problem.
for
But in
this one-
36, it's just write the sample space.
Okay.
F1, F2, so yeah. Maybe,
Okay.
maybe. Okay. Yeah, because I didn't really talk much about sample space, so that's a valid question to ask. Like, what the shit is a sample space? Oh yeah. Let me think. Where was that other problem? The dice problem? Here it is. So the whole thing with probability is it's easier if you give yourself everything to count, and you can't escape it. Part A says you have to put the sample space. But then do you see like part B? Let A be the event that a 3 or a 4 is rolled first, followed by an even number. What is the quick way to find the probability of that happening? If you knew how many total things happened, and you can count how many things match what you're looking for. When you just do the ratio of those things, yes? So that's why they want you to make the sample space, because then you can answer that probability question easy. You just count everything that does that, divided by 36 things. No? Yes? No?
Yeah.
Okay. All right. It just looks like some of you guys want to cause me harm. I never know how to take it. Yeah. I hate this shit. All right. Anything else from homework stuff? I think I'm done asking my questions as a student. Anything else from homework stuff? How about from the practice quiz? Have you guys had a chance to even glance at that thing? Anybody need a copy of the practice quiz?
Wait, is that all the answers?
No, I got that up here.
Oh.
This is the blank. So one side we did it in class, and the other side is the practice quiz. I do have the answers. Just not gonna give it to you yet. Any questions from that? You guys doing okay? Seriously, are you doing okay? Yeah. Okay. So let me go ahead, I'll just give this to you. Let's see if it generates any questions. get everybody? Okay. Yeah, so you can look that over. Let me know. See right here, this problem here? The one about independent. So I did, part A is the probability that they're identified as a man. Part D is man given Toyota. So if they're asking me, are being a man and owning a Toyota independent, I want to see if they affect each other. That's what I compare. All right, so the probability of being a dude was 50% chance. But the minute I knew they owned a Toyota, that went down. I like it. Do I have a Ford into it yet? I don't have a Ford or a Toyota or a Hyundai, so I don't care about what you think about who's better. I don't give a shit. If you have any strong feelings. All right. So let me know if you have any questions on that. The actual quiz is obviously not going to be exactly these questions, but they're going to be questions like this. You know I'm going to give you a chart. You know I'm going to give you something related. It's not going to be candy bars. But there's going to be some stuff somewhere, and I'm going to pick something with replace without, right? Same kind of idea. Okay, maybe. And you know I'm going to give you a problem like that one. It's not going to be about a GOP budget plan, hopefully. Because that one, I mean, way too exciting. So I'll try to tone it down for the actual quiz. Okay, all right. No questions there, so all right. That's fantastic. We're going to get to chapter 4 now. Yeah. Now, the funny thing about chapter 4, it will hopefully make something from chapter 3 actually make a little more sense. So let's see if that happens. So what we're about to do in chapter 4 is, for example, let me give you an example from real life. Is anyone not quite 25 yet, but you pay car insurance? Okay. Anyone over 25? Yeah, everybody else. Do you remember what happened when you turned 25 with your car insurance? It goes down. So if you're not quite 25 yet, you can look forward to a decent reduction in your car payment, your insurance payments. Why does that happen?
Because you're supposed to be better by then.
Yeah. Somehow on the day of your 25th birthday, you wake up and you go, oh, that's what blinkers are for. Shit. Of course, I think there's a ton of people that just never have that happen. Anyway, sorry. I'm not going to go on my rant, my old man rants about people on the street. Yeah, neighbor. All right. So what really is happening behind the scenes is the insurance companies know the probability that you'll cost this much money to them given that you're this age. So there's actually a table you can construct to calculate the average amount of money that I would pay out if I am the insurance company. Are you guys semi with me? I mean, there's a lot of detail to fill this in, but you can construct a table. It's got to have some kind of like ages for each row, and you can actually figure out what's the average amount that I would pay out for a certain age group. Right? It would actually be this amount of money accident, this probability, this amount of money accident, this probability. So that's how they set where your premiums are. So once you go from 24 to 25, you're in a whole new kind of like age bracket. And those probabilities of accidents do go down, right? Of course, individuals can buck the trend. We've all seen this. My quick. Who are the the slowest, carefulest drivers?
Old people.
Now, here's my
Okay.
theory. They got old because they are careful drivers. Does that think about that for a second? Right? And I'm not doing a public service announcement. I'm not the most careful driver. I'll admit to that, right? But it suddenly struck me one day. I'm like, well, they made it to that age because they weren't in as many accidents. That's why because one day I saw somebody came up behind me, they got around me, they cut me off. I'm like, oh my God. And then I saw it was this little old woman. I'm like, oh, she's the one that's still alive. And it's probably, there's a probability that you're going to survive. Anyway, sorry. Everybody's like, dear God, make this guy shut up. Okay. So that's just my guess. So what we're going to do, I'm first going to do something that you just have to come with me on. We're going to do something that seems unnecessary. And then I'm going to immediately show you why it's necessary. So you just got to come with me. And the reason I'm going to do what I'm about to do is it explains the math behind the process we use. Okay, so here we are. So if I had this data here, all right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yay, Jeff. That's my data, right? So let's take a big old step back. And let's say, how would I calculate the average? of
Add
that
them all
data?
up and then divide it by 10.
Holy shit. So to do that, can't I be a little smart about it? What I mean is this. 4, 1, I'm sorry. Yeah, Jeff. All right, wait.
A little
Let me make
smart.
Sure. Let me make sure. Yeah, that was good. Yeah? All right. Let's try to be a little bit smarter. Here we go. 3 1s plus
4 2s.
4 2s plus 2 3s plus 1. Is everybody cool with that? Right? Divided by 10, because there's 10 of them. Yes? Okay. I like it. Amazing, right? Ooh. So, the old way would have meant 3 plus 8 is 11, plus 6 is 17, plus 4 is 21. Somebody double check because I couldn't count 3 things, so make sure I added that right. I don't trust myself. 11, 17, 21. Okay, I feel a little better about it. Is that all right? Okay, so I don't know if you guys are concerned about this. You're concerned about that, right? Like, what the shit, Jeff? So again, I'm going to remind you, we're about to do something really silly. The work is more than it needs to be, but I'm going to immediately show you a problem where I go, thank God that we have this other way to do shit. So, we already know what the answer is supposed to be. So whatever new thing I do, it better come out to be frickin' that. Couldn't I do this? Is everybody cool with that? Right? Can I do that? That's what it is. 3 tenths times 1 plus 4 tenths times 2, blah, 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 yes?
Okay.
I'm dividing everything by 10, right? So everybody gets divided by 10. Again, I'm sure out there you're going, all right, math boy, why? What's wrong with that? What the shit are you doing? All right, stay. Isn't this like, why does this make sense? What percentage of my numbers are 1s?
3. Oh wait, 30.
30% are 1s. 40% are 2s. 20% are 3s. 10% are 4s. And I know it. I can read your mind. You're like, this is more work with the shit, Jeff. Well, I'll get it. Or actually, I can't. I don't know. I have no idea what you're thinking, to be honest, when I look at you. All right, we'll find out in a minute. Again, are you okay? Now, would you do this? Would you do this? Would you have done this yourself?
No.
Of course not. Do you understand the steps, that they do work?
Yeah.
And they're sort of like, this is what a math person does on the board. Feels like, right? We just play around with numbers. But does this come out to be the same thing? 0.3 plus 0.8 plus 0.6 plus 0.4. What do you get when you add all that up? Not surprisingly, you get
2.1.
2.1. Same thing. Of course it's the same thing, because it's the same math. Okay, now. We're almost to the point where I actually show you why this is good to know. The way that this chapter is going to give me this data is not like this. The way this chapter is going to give me this data is like this. Do you see how that's the same data?
Yeah.
So what's probably a pick of 1, 30% chance. What's probably a pick of 2, 40%, and so forth, right? So it gives me the data points, and it gives me the percentage or the probabilities of each, right? And very often we call this the weight of each data point. What's the heaviest weighted data point?
2.
2, right? That happens 40% of the time. Now, the biggest mistake people make is when they see this, they think the data is 1, 2, 3, 4. That's not correct, right? There's more 2s than there are 1s. In fact, what is the average of 1, 2, 3, 4? What's the average of 1, 2, 3, 4?
2.5.
2.5, right in the middle, right? Why did our average come out to be 2.1? Because there's more 1s and 2s, less 3s and 4s. That pulled the average up, away from 2.5 to 2.1. Does that make any sense? That's why this idea of weight is awesome, because it's sort of like a gravitational pull. Come to me. Yes. All right. Okay, so let's do another problem in that setup that will immediately tell you you don't want to do it like this. Couldn't I rewrite this shit like this? And then just do like we did in chapter 2, right? Yes? So watch this. What if my data was this? By the way, when you do this, leave some room. We're going to do more shit. What if my data was this? What do you got, Jeff? You can do it, but look at you writing shit. There you go. Sure, let's just do this. Oh, crap. Are you really going to do that? Oh, shit. Okay, dude. Oh, shit. All right, here we go. Give me a second. 8, 9. So that would be 1, 1, 1, I think. What am I trying to be careful about?
I don't know.
There was something I was trying to be careful about over there. Does anyone know? Add up to 100%. So do you see how many I just made up totally? The first 3, right? I'm a little careful. But then the last one's better make it freaking 100%. So double check me. Does this add up to a 1.000? Are you guys doing it in your head? I see people are just staring at it. All right. Oh, you're going to want a calculator, right? Anybody need a calculator? You're going to want one like right now.
Yes, it does.
It does, good. Huh?
Yeah.
You need a calculator?
Oh, no.
Oh, it does add up, okay. Very happy for your enthusiastic answer.
I finally got it. It took me a long time.
Everybody else is good? Oh. Whoa, look at me disrespecting. All right, thank you. Make sure they turn on before you get too far away. Okay. Now, I want you to really understand this. Do you see how this translated directly to 3 1s, 4 2s? Right? So if you really wanted to, you could write 3 1s, 4 2s, and then do it like chapter 2. I really want you to understand what I just said. Isn't this 3 1s, 4 2s, blah, blah, blah? What would this be then? 121 2s. All right, no. No. 452 3. You want to make a list like that? No. Now we just got to understand how this math works with the table. And of course, what did this math really need me to do? Multiply the weight times the value. Add it to the next weight times the value. Do you guys see that?
Yeah.
So this column, I want it to be this. Who's doing it? All kinds of shit. That's exactly what we did down here. We didn't do it here because we knew that. We did it here because that's just what the math said to do, right? So we're just capturing what the shit we did that made sense. All right, so somebody help me out. Twice 0.121 is remarkably enough 242. 3 times 0.452. Oh shit, what is that, Jeff? 1.356? That can't be right.
1.356, yeah.
Look at Jeff go, and then 4 times this, 1.264. And this one's gonna be hard. Oh, jeez. Make sure about that. I don't know. Today, I don't know. All right. So I really, really want you to understand what we just did is exactly like this step here. It's exactly this step right there. So to be honest, we're doing the exact same math we did in chapter 2. We're just doing it in a way that works with this way of giving me data. It's not a list anymore. So I had to develop a process that makes it easy to figure out the mean. So now, how do I get the mean? Where's the mean come from? What do I have to do?
It's the most repeated number.
No, careful, that's the mo.
It's the,
No, stop, try to, right here. What did we do after we got all these multiplied? We just added them, right?
yeah.
So I'm just gonna add this. So I'm gonna add this. Remember that? I got a bunch of x's. I'm gonna add them. So somebody help me out. 3.417.
3.399.
Ah, damn. I feel pretty good about that. 3.399?
3.399, yeah.
I got this up. Oh, anybody else do that?
Hold on.
2.6.
Oh, wait, no, I did it wrong.
What did I say? I'm pretty sure I was
Yeah,
right.
I did it wrong.
3.417.
Is that what it is? I think that's what it said. Yeah. 3.417. Is that what you guys are getting out there? Somebody? Yes. Okay.
Yeah,
That is the mean of that data. Sweet. I like it. And it makes sense because the two heaviest weighted things are 3 and 4, so it's just a little closer to 3, right? Instead of being at 3.5. I don't know if you guys are with me on that. Right? The heaviest weighted stuff should be around where the mean is, or it's going to influence the mean the most. In fact, how do I do grades in this class? Remind me? I know, but I'm new. Do you guys remember how I do grades? How do I calculate grades? Anyone looked at the syllabus? Do you know? Do I calculate grades? Maybe I just roll a die and just B. Failed. That'll make it
Don't
easy.
you average them?
How?
By adding them all together.
No.
No, they're all weighted differently.
They're weighted differently, right? Isn't that weighted differently? Isn't the test like 50 or 55%?
Yeah.
Remember that? Yes, this is coming back. Isn't that the same as this shit? Those are the weights. So I would take the test average times 0.55, whatever, plus quiz average times 0.2, whatever. Final exam times 0.2, whatever. Right? Are you guys with me? And then add that up, and that's your average. Yes, that's how that's done. It's exactly the same idea. Now, so the mean is certainly important. Become the mean. Okay, that's good. The mean is important. What is the other number that we need to be able to calculate that's also important? There's two numbers I can use to summarize any set of data: the average and
The spread.
the spread, standard deviation. So I need to have a way to figure out the standard deviation. Okay. I should have told you. We're going, there's a little more here. I have no idea how much what your notes are going to like. All right. Let's do this. All right, let's do this. A little side note, because we're not going to use the formula directly. We're actually going to use we're going to make it better. That sounds good. Except you're not going to believe it. Now, real quick. Let me do this before I forget. What was the formula for the mean before? If I just had a list, the official formula.
The sum of data points divided by n.
Okay, right? Is that cool? Look at the one we have now. What is the main difference there? Oh, thank you.
The p times x, probability of x.
All right.
X.
Oh, there it is. Wait. Somebody else tell me. Sorry, Matt. I want to make sure everybody. I want to make somebody else talk. What is missing in the second dude? The n. Yes. Right. And of course, the p of x is there. But somebody remind me, what is on the bottom of a probability?
The number.
The total number, right? So n is on the bottom of this. So aren't these are basically the same formulas. I really want you guys to see that. Doesn't p of x have an over n built in? Yes? It's built in. I don't know. So they really are the same formula. Right? Okay. I feel like I'm trying to convince you that I was abducted by aliens, but they really are the same formula. They really did get me. And a cow. You're in the air. Okay, so now the main idea here was I don't just add the values. I add the values times their weight. Okay, so no. How did we do standard deviation? Well, let's do variance actually. A little easier to talk about. Variance was this bad boy. Does this look familiar at all to anybody? Right, this section 2.7. Right, this. So I desperately want you to completely see this. You see how p of x is doing the same thing here as it did before. I'm not just going to add up these, I'm going to add up these times their weight, and the over n is built in. Again, same formula actually. All right. This next part is the part that I thought you were going to zone out about, but a few of you guys have zoned out already a little bit, so I'll just expect everybody to join in. But you got to stay with me. We're going to do, get ready. Here we go. All right. This formula sucks so much. I don't know if you understand. Do you understand what I would have to create here to get what I need there? When I have to get what x minus the mean is, and then square it, and then multiply it by the probabilities, and then finally add this shit together. So I'm going to create with you some help. We're going to make a formula that I don't think you're going to believe me is easier. Then we're going to do an example, and you're going to say, oh shit, that's easy. So let me look at this specifically. Is that? All right. This piece of it, let me write it again, and then I'm going to focus on a piece of it. All right. Think in terms of algebra. If your teacher in algebra gave you this and said simplify, what would you do? Do you remember?
Apply the square to the individuals? No. Okay, just starting.
Yes.
Two equation, x minus mu, and then another one.
Yes. And then you would do this 4-letter word starts with F that you can say and makes
Factor.
Foil.
Foil.
4-letter word. I don't know how you spell factor, so. FCTR. Factor. Okay. So yeah, you'd have to write this twice, because that's what square means, right? All right, go ahead and foil that. I'll wait. Give you a little memory of algebra here real quick. see who remembers. Did you guys like FOIL? Do you guys remember foiling? Do you remember what FOIL even means?
I don't know if I don't think I did it right.
Yes. So whenever I teach that section, I like to point out that FOIL is bullshit. FOIL is bullshit. Sorry. Any colleagues that teach FOIL. All it is repeated distribution. You don't need FOIL to remember. X gets a term, distributes. Mu gets a term, distributes. I don't need no freaking FOIL. Sorry. I don't know why I'm getting worked up. Stupid thing. But whenever we develop things like that, it's like we're communicating, hey, this is really hard unless you have this thing to remember, when it's just distribution a couple times. So it's not a difficult thing. So what's x times x?
X squared,
X times negative mu.
negative x mu.
Okay. And then negative mu times x, another one of these. And then negative mu times negative mu
Mu squared.
plus mu squared. So you get this thing. All right. Stay with me. Stay. I swear to God. I'm going to skip a lot of steps because this is not about summation algebra, right? I just wanted that one little piece for some help. So let me bring in the rest of this. Let me surround this thing with the rest of it. So I'm going to put this right here. Right? All right, here's where I skip a lot of steps. What's the first thing you would get when you distribute that P of X, right? When you do blah, 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 right? Right.
Okay.
So the first thing you would get would be the sum of x squared P of X, yes? Is that cool? X squared times P of X. Is that cool?
Okay.
You guys see that? Just distribute the P of X, right? I love you guys. It's like you guys try so hard to not give me any information. Is that all right? Yes? Okay. Now, here's the part that, if you're interested, I could show you the steps, but I'm not going to do it right now. All the other shit becomes this.
Yeah.
All this other shit, if you work out the stuff, it becomes that. Believe it or not. Now, how is that formula better, Jeff?
That's the end formula?
That is it.
Okay.
And I really want this to understand. How does this formula relate to that formula?
They're the same.
They are the exact same. We just rewrote one of them a little bit. Does this look better than this? Be honest. Does that look better than this?
No.
No, I love it. There's an honest answer. Right? I'm going to show you how it's better. Do you guys remember about covering the sum symbol to see what column I need? Right? If I cover the sum symbol, what column do I still need?
X.
I need a bunch of x squared p of x's, yes?
Yeah.
Does that make sense?
Yeah.
Okay. Just like here, I need x p of x. That's why we made x p of x, so we can add it. Now I need x squared p of x. Okay, that's easy. I just need x squared p of x. Let me see if I can get you on my side about this. Here's the way I get it. Thank you. I just do this times this. I do this times this times this. What is x times x p of x? What is x times p of x? What is x times x?
So,
X squared.
okay.
So don't multiply these together. Doesn't that make this?
Yeah.
Yeah, so if I want to be a little more specific, can you imagine putting that in L1, putting that in L2? This is L1 times L2. This would be L1 times L3. So what's twice 0.242? 484. What's 3 times 1.356? I might need some help. 4.168. Somebody help me out. 3 times 1.356. okay if I'm totally wrong, it's fine.
066.
066?
6-8.
Oh, 068? Okay. Is that what you guys got?
Yeah.
Okay. And then 4 times 1.264, what's that gonna be, Jeff? 5.056. Is that right? Look at me go! All right, sorry. And then 5 times 0.555, I don't know, shit. I don't know, maybe not. 2.7 something. 2.75?
2.775.
775, okay. Holy shit. All right. Right? I mean, good Lord, there's a lot of stuff going on. So, when I add this column together, that is just a piece of what I need. So let me kind of get stuff together over here to get ready. All right. So the mean was the sum of xp of x, which is exactly that number. The variance is the sum of x squared p of x minus the mean squared. So somebody help me out. What is the sum of these? Has anyone done that yet?
12.383.
12.383?
383. Yes.
Sounds about right. So now just put that here, right? That goes there. Minus what squared? Minus, what's it say?
would be
Don't overthink it. Don't overthink it. What's it say? Minus the mean squared, right? What's the mean? Then we just calculate it? Then we just calculate the mean? Yeah. 3.417. We just did the mean. There it is. So minus the mean squared. Bang. The most common mistake is people forget that square. Poor little dude. So what's the variance then? Somebody help me out. Do your own damn math, Jeff. All right. I'll do it. Let's see. Anyone else get this? Yeah, okay. And is that what I want? Good. I want the standard deviation, which is the square root of that. That looks like, sort of two, anyway, sorry. I'm making too much out. 8, 4, 1. Bam. Crazy. I really want this to make sense. Is that a big spread? Is it really spread out?
no.
Hell no, because I got like 121 twos, 452 threes. I mean, the data is stupid close to each other. Yes? The mean is 3.417. Do the data get very far away from that? Shit, no. They're right next door to that. So that makes sense. That thing is small, it makes sense. Okay, so let me give you this. I don't know if you're going to believe this, but I have a handout. One side is a completely worked out problem, and the other side is completely not worked out. It's for you to do. So. So real quick, I think, let me show you one thing here real quick. Well, actually, we can do, yeah, let's do this. We'll do this problem. You're gonna need your calculator, Joe. Oh, yeah. real quick. Let me just, I know this problem is done, right? You guys see that all right?
Yeah.
My poor calculator, my nifty one is all dead. Revive it. All right, so I got a lot of crap. Clear. Let me old calculators. All right. Now, I can put all my x's into L1. Then I can put all my p of x's into L2. Come with 4. Okay. And then I'm really, really nice on this handout. What do I want L3 to be?
L1 times L2.
Yeah, I want it to be my x's times my p of x's. X's are in L1, p of x's are in L2. I just want to make it L1 times L2. So I go up to L3, and I tell it, make this list L1 times L2, bam! See the same numbers? Yeah! Go team! And then of course I want L4 to be L1 times L3. Now couldn't you, let me see if I can, couldn't you make L1 squared times L2? Wouldn't that be x squared p of x?
Yeah.
Okay, you kid if you want to. I just always do L1 times L3. Why do I do that? Because I don't have to hit the squared button. It saves me one button. You feel about that as you want. So same numbers here, right? Yay! Okay, so go ahead, try to fill this table in, see how many of these you can answer down here. My plan is to let us out a little early. Let's see if you guys can make that happen. No pressure.